we're going to be concentrating on section 2.6. And we're going to review some of these different ways to describe function. So a function is a relation in which for each distinct value of the first component, remember that would be x of the ordered pair, there is exactly one value of the second opponent. So basically for each x, there's only one possible y. Now you can have multiple y's, but you cannot have multiple x's. The second definition says a function is a set of distinct ordered pairs in which no first component is repeated. So that's a little bit nicer of a definition. The third definition says a function is a correspondence mapping of or an equation rule that assigns exactly one range value to each distinct domain value. I feel like the best one for you guys would be the second one. Okay, so we're going to talk about function notation for a little bit. That's one of our objectives for 2.6. The other objective is graph a linear and consistent functions or discuss them. So what we're going to do here is we're going to discuss naming of a function. So what you guys have to think about right now is that you're used to doing y equals something, and we're just going to replace y equals with the f of x function. So it's literally stands for the function in an x value, or a variable of x. And then we'll have our defining expression, which you guys are used to seeing. So for exercise 1 here, we have f of x equals 4x plus 3. And for a, we want to find f of x equals 4x plus 3, but we want it for x equal to -2. So all we would do here is we're going to replace x with -2. So f of -2 equals 4 times -2 plus 3. So when we solve that, -2 times 4 will give us a -8 plus 3 would be a -5. So you can say here a few different things. You could either leave it as -5. Okay. You could write it as the point -2, -5. This is what I would prefer on an exam. Okay. You could say y equals -5. All right, that's also allowed. You could even say f of -2 equals -5. So again, this is the one I would prefer on a test. Pearson could take any of these. You just have to pay attention to the way that they are asking you in the directions. All right, here we're going to do the same thing. We're replacing x with 0. So f of 0 equals 4 times 0 plus 3. The 4 times 0 cancels out. So 0 plus 3 equals 3. Okay. Again, you could write it as a point, 0, 3. Right? We know that's actually the y-intercept. But again, I would prefer it as a point on the test. Pearson could ask for y equals 3, f of x equals 3, but they would actually use f of 0 here, sorry. All right, any of those options. Okay. Questions on that, we can go over it again during the review, or you can pause it and rewatch and do it again. Okay, so these are very similar, just a little bit different. So f of x is now going to be 2x squared minus 4x plus 1. For a, okay, we have f of -2, so really the x is -2. So it'd be 2 -2 squared minus 4 times -2 plus 1. So f of -2 equals -2 squared is a 4. So 2 times 4 minus 4 times -2 plus 1. And that's going to give us 8 plus 8 equals, or plus 1, sorry, equals 17. So you could write that as a point, -2 comma 17. You could leave it as just 17. Again, for the test, please give me points. B is a little bit interesting. B is giving us another variable, saying f of a. So all we have to do here is wherever we see an x, we're now going to put an a. So 2a squared minus 4a plus 1. Okay, and that's all you have to do for this one. Okay, very similar is what we're going to do in the next example. It's saying g of x is equal to 8x minus 5. But then it wants g of a minus 2. So we're going to plug in a minus 2 here. But we can't just leave that. We have to make it look nice. So g of a minus 2 is going to be 8a minus 16 minus 5. We got to combine these. So your final answer is g of a minus 2 is equal to 8a minus 21. Very good. Okay. All right. So for this type of problem, you're looking for each function, you want to find f of -1. So here you're just going to look for where x equals -1 for a. Well, x is -5 here, so that's not it. X is -3 here, so that isn't it. So we find x equal to -1 here, and then we care about the y. So you could write this as f of -1 equals 4. Right? You could also write it y equals 4, or you could give the whole point. On the test, I would give the points for however you wanted to do it that way. Okay. And then here again, we're going to plug in. So f of -1 would equal -1 squared minus 12. Well, that gives us 1, positive 1. Minus 12 gives us -11. So the point here would be -1, -11. Just stick with -11. Okay. For part 5 over here, exercise 5, you're looking at the figure 7. Okay, and if we have to find -1 here, well, we want to look for x is -1, so that's right here. So that is at the point -1, 0, or y equals 0. Okay, either way. For what value of x is f of x equal to 2? Well, now we have to go to 2 on the y, right? Because if they're giving it to us as an output here, then it has to be a y. So when is y equal to 2? Well, we have to come to 2 here. If we would look at the 2 there, is that hitting the line? It's not hitting the line. So we want to come over to where it does hit that line. And it hits that line at the point 1, 2. So you're looking at an x equal to 1. Okay. Again, you can pause, repeat, whatever you need to do in these videos to make sure you're understanding those concepts. Okay. This is an example of how we are going to write an equation using function notation. It says step 1, solve the equation for y if it is not given in that form. You can see we're going to have to solve for y. And then we simply replace y with f of x, and that's all we have to do. So we're going to add 4x squared. Oh, I apologize. Add 4x squared on both sides. So we would have y equals 4x squared plus 5. And then we're just going to replace y with f of x. So f of x equals 4x squared plus 5. All right, that part is done. The second part says find f of negative 3. So f of negative 3, let's do a different color so you can see it a little bit better. So f of negative 3 is equal to 4 times negative 3 squared plus 5. Negative 3 squared is 9. So 4 times 9 plus 5. So we would get 36 here plus 5. So your overall answer out is a 41. And if you wanted to do the point, it would be negative 341. Okay. All right. So this is just a regular typical taking some notes that you want to take down slide for you. Some things you might want to pay attention to. This part, of course, you already know. It's pretty similar to your slope-intercept form or your y equals mx plus b. So don't feel like you're no longer understanding what's going on. You've been working with this all last chapter. Here are some good examples of what functions can look like. So what you want to pay attention to here too as well is domain for a linear function will always be negative infinity to infinity unless otherwise specified. Okay. The other thing you want to take to note is that the range of a linear function that has a non-constant linear function, okay, we're going to discuss what the other part means in a second, is also negative infinity to infinity. However, a constant function, which will look like this, and you're used to seeing it as this, or y equals a number, then the range becomes just b or just the number, okay? So you can pause the video, you can take your notes from that, however you want to take it. That's what it looks like there. Okay. All right, graph of each function. Give the domain and range. All right, I think I have this on again. Do I? Yes, I do. So we're going to focus on A for this one. And then we'll do B on this one. All right. So graph each function. So we're going to graph A. Let's graph A in red. So we're going to come down to -2. And then we're going to go up 1 and to the right 3. Up 1 to the right 3. Up 1 to the right 3. Oh, I didn't go 3 the second time. Up 1 to the right 3. Up 1 to the right 3. Down 1 to the left 3. Down 1 to the left 3. Down 1 to the left 3. Okay, and then you're going to graph it, or, do your line. And unfortunately, oh, actually, you know what, guys? I have let's do that again. I have a ruler with me, and let's see if I can get this a little bit nicer for you. So again, up 1 to the left 3, down 1 to the left. Oh, you get the idea. Sorry for my miscommunication. Oh. That was my finger as the ruler was falling. Okay. Oh, man. Oh, boy. Guys, is just moving around on me. Okay. We did it. We did it. Some weird things happened while we did it, but it looks like a decent line. I guess it moved a little bit on me. I wonder if I can move it a little. No, I can't. All right, it's fine. We're gonna work with it. So, stop that. Okay. All right, let's just work with it. So we want to talk about the domain. Right, the domain. And we know this is a linear function, right? So we know that domain, without thinking about it, is going to be negative infinity to infinity. Solid. It's not a non-constant. It has a slope. So you know that it's going to be negative infinity to infinity for the range as well. All right, so that's that one. Okay. Now we need to graph the second one, and we just have to go to where y is equal to -3. So that's right here. Let's see if this thing will work with me again. It's not exactly, but not too bad either. So this is f of x equal to -3. Okay. All right, so I think that's the last time we have to draw for this moment. We'll see. What you can notice here is that your domain, again, it's a linear line, so it's going to be negative infinity to infinity, but pay attention to your range. Do you go the entirety of the y-axis? So if you're looking at the y-axis and you were to describe to someone what's going on with the y-axis, well, you're not hitting every point on the y-axis, are you? Okay, you're not. So you have to pay attention here, and you have to realize that you have a point on the y-axis where that line exists only in one spacing. So it only ever has a y of -3. So because of that, the range is -3. Okay. All right. Here is your exam 2 bonus for section 2.6. It is on Canvas. All right, and that is the end of the recording for 2.6. If you need anything, make sure you ask during our review. There are only 6 sections on the next exam. So 2.5, 2.6, 3.1, 3.3, 4.1, and 4.2. I'm probably going to go ahead and record all of them today. I don't know if I will upload them all or if I'll allow you all to have access to them prior to us going over them in class, but they will all be recorded, so you won't have to wait as long to get them. All right, I'll see everybody in class on Monday. Have a great day.